My name is Laura Johnson. I'm a research scientist with the National Center for Water Quality Research at Heidelberg University. My research focuses on nutrient pollution and its impacts on Lake Erie. For 3 days in August 2014, hundreds of thousands of Toledo residents couldn't drink their tap water due to a dangerous outbreak of cyanobacteria, commonly called a harmful algal bloom, in western Lake Erie. This was just the latest harmful algal bloom in western Lake Erie. It's happened before, and it will keep happening unless we tackle the source of the problem. We know that harmful algal blooms in Lake Erie are caused by excess dissolved phosphorus in the water. This phosphorus feeds the algae and bacteria so they grow explosively and cause problems for drinking water, fisheries, and other uses of the lake. How do we know that dissolved phosphorus from nonpoint sources and heavily agricultural watersheds is causing harmful algal blooms? While phosphorus pollution can come from many sources, in this case, the dissolved phosphorus is largely coming from agricultural lands. So how do we know this? It's a tale of two rivers, the Maumee and the Cuyahoga. Heidelberg University's National Center for Water Quality Research has been collecting nutrient data from these two watersheds for nearly 40 years. There's a big difference between these watersheds, and it has to do with the land use surrounding these rivers and the streams that feed them. The Cuyahoga River watershed contains a lot of urban and suburban land. The phosphorus sources in this watershed are mostly what we call point sources. A point source is usually a pipe that discharges into a body of water like the one from a wastewater treatment plant or an industrial facility. The Maumee River is mostly agricultural lands, which means it's full of non-point sources of phosphorus. A non-point source is often land runoff. Here's why this matters. Pollution that comes from a discrete source like a pipe, point source pollution, gets diluted when it rains. The phosphorus coming out of the pipe mixes with the higher flow in the river, so you've got less phosphorus per gallon of water. But with non-point sources, like the water that runs off a farmer's field or a roadway, rain can pick up extra phosphorus from these surfaces and carry it directly into streams and rivers. That means more rain and more water runoff, measured as discharge in blue on this chart, leads to higher concentrations of phosphorus, the orange points, exact opposite of what happens with point source pollution. How do we know which source of phosphorus is contributing the most to Lake Erie's harmful algal blooms? Here's our first piece of evidence. Since the 1970s, pollution from non-point sources has gone up and down consistently. But pollution from point sources has declined sharply and has been fairly steady or even slightly declining since the 1980s. Yet, over the past few years, harmful algal blooms have become a bigger problem than they had been in decades. In 2011, Lake Erie had its biggest on-record outbreak of toxic algae. This photo, from September 3, 2011, shows a massive algal bloom covering the entire western basin of Lake Erie. Yet, on almost the same date the following year, in 2012, there was hardly any toxic algae visible. What made the difference? It's all about the rainfall and the subsequent amount of water runoff or discharge as we measure it. In 2011, we had strong spring rains that caused a massive spike in phosphorus loads from agricultural lands in the Maumee River watershed. In 2012, by contrast, we didn't get the heavy rains and we didn't get those big phosphorus loads in the Maumee, and Lake Erie was spared a big algal bloom. In 2013 and 14, discharge and load were up again, and both years had larger algal blooms. Look at the same 5-year period from the Cuyahoga River. We can see that increased discharge did not result in increased phosphorus load. In contrast, phosphorus loads have been fairly steady. Let's look at 2014. You can see a number of storm events in the Maumee River from March through June. For each increase in discharge, concentrations of dissolved phosphorus also increased. Notice the same 2014 rainfall events did not cause phosphorus concentrations to spike in the Cuyahoga. That's the second piece of evidence. Big spring phosphorus loads in the Maumee and a big algal bloom that summer. So, to sum up, Watersheds that are primarily characterized by agricultural land use are showing big spikes in phosphorus from non-point pollution after big rains, as indicated in the top chart for the Maumee, compared to no significant spikes in the urban suburban Cuyahoga. Those big phosphorus loads from agricultural watersheds are seen in every year in which Lake Erie has had a major algal outbreak, as indicated in the lower chart showing bloom severity. Where we've had low or no heavy spring rains in an otherwise normal year, like 2012, we've managed to avoid a big algal outbreak. The good news is this. Our research shows that if we slash phosphorus pollution, we don't need to wait years and years to reap the benefits. Decreases in phosphorus pollution will have an immediate impact in the same year. If we can prevent heavy rainfall from carrying phosphorus into nearby streams, the problem would be dramatically reduced. This is a problem we know how to solve. We've already reduced the amount of phosphorus associated with sediment from leaving agricultural fields. If we reduce the amount of dissolved phosphorus that runs off of agricultural lands, we'll make huge strides towards preventing future emergencies like the one that hit Toledo in 2014. And that has implications for lakes and rivers around the globe that are struggling with harmful algal blooms. I'm Laura Johnson from Heidelberg University's National Center for Water Quality Research. You can learn more at lakeeriealgae.com.